Alright, so in this tutorial here, I'm just going to give you a quick walkthrough of how to use this variable power supply here. We've definitely plugged in this power supply. This power supply can actually send in both direct current DC as well as AC. For the electrolysis reactions that we're going to be doing in class, we are only going to be needing this DC voltage here. You can dial this knob here, so I'm going to crank that up to DC. The DC outputs, the positive and negative terminals are on the right hand side. If you did use AC here, it's on the left hand side here. We do have a sort of voltmeter here. Right now here, the dial is cranked all the way to minimum, so right now we're sending in 0 volts. As I crank up this dial here, the voltage across the two terminals here will get higher based on an Ohm's law sort of relationship here. Depending on the sort of resistance of the solution, not only can we read the voltage here, we can also read the amperes, which is the current as well. So for this demo here, I've connected the two leads here using alligator clips. Both of these are actually holding onto carbon graphite electrodes, so I'll let you take a look at what it looks like previously. And then what I'm going to do just for demo's sake here is I'm going to take a 1 molar solution of copper 2 sulfate. Right now here it's this clear blue solution here. I'm going to load up this U-tube. The U-tube just allows me to more easily see what's happening at each electrode. So that one there is copper 2 sulfate. It is technically just one container there. What I'm going to do here, just show you how the voltage here can be changed. So you can just dial this up here. Right now here it's just in the air, so we can crank it all the way to a maximum if you want to. Okay, careful when the voltage gets too high, so that's maybe 14, 15 volts there. I'm going to keep it at about 9 volts, so you can imagine this is a fancy 9 volt battery. Obviously here it's variable, so you can get any voltage in between. Also it's a continuous power supply, so we're not having to buy fresh batteries every time. But just for demo's sake here, we're sending in 9 volts. I'm going to drop in the electrode on the one side, and then I'm going to drop in the other electrode on the other. And then we're just going to leave it over time here to see what happens to these solutions here. Basically in our calculations we can figure out here based on the current that I'm sending in and based on sort of how long I'm waiting in time, I can figure out how many charge I'm actually putting in, how many electrons are actually being transferred, and we can actually use sort of a mole relationship to figure out how much, let's say it forms a solid precipitate, how much grams of solid actually forms. So I'm just going to wiggle this around a little bit here, maybe you can see it a little bit better. Similarly on this side here. Okay. Again, the longer that I'm waiting here, we're just sending in more current for more time, so more charge is actually being transferred. We'll use Faraday's constant here to actually calculate how many moles of electrons are being transferred. When you're all done, I would crank the power supply down. Okay, I would dial it back down to a minimum just for the next person. And I'm just going to show you what it looks like on either side here. I'm just going to try to shake off any leftover that's formed here. Okay. And then just comparing the electrode surfaces themselves. Okay. We do see a little bit of cloudiness on either side here. That's actually indication that a solid has formed. You can even see some of the solid has actually deposited on the electrode surface. So surface area of electrodes is going to be important. So make sure that you maintain contact between the electrode as well as the solution. But there we go. That's how we use a variable power supply here and also an electrolysis demo. Thanks guys.